Hi everyone, this is Amy from the Helms Academy, and today we are talking about the Pythagorean Theorem. So today we'll be looking at some key terms. We'll be identifying the meaning and history of the Pythagorean Theorem. We'll also be solving for the missing side of a triangle using that theorem. Let's get started with some key terms. First of all, we'll be working with triangles. And a triangle is a plane figure, which means it just is 2D, not 3D. And it has 3 sides and 3 angles. A right triangle, though, is a specific kind of triangle that you can see on this page down at the bottom. And a right triangle is a triangle that has one right angle. A right angle is a perfect 90 degrees. A hypotenuse is a fancy name for the longest side of a right triangle. And it's easy to find because you just have to find the right angle and then go directly up from there, and it'll show you which side is the longest. It'll be exactly opposite the right angle. So the Pythagorean Theorem is a formula that will help us determine the side lengths of a right triangle. So if you're missing one length on a right triangle, the Pythagorean Theorem makes it possible to figure out that length using the other sides. So a little bit of history here. This is Pythagoras. Pythagoras was a Greek mathematician who was born in the year 569 BC, and he's credited with proving and teaching this theorem. So here's how it works. The theorem is used for finding the missing side length of a right triangle. So you can see here a triangle in the middle of these 3 boxes. So we have side A, side B, and side C. Side C is always the hypotenuse. It's always that longest side of the triangle that's opposite the right angle that you see down at the bottom between A and B. So this idea is that we have A squared plus B squared equals C squared. And what that means is that the length of A, if we square that, right, so it would be that length times itself, which would be like how we get area of a square. B squared, so the side length of B times itself, that's equal to the length of side C squared. So with this equation, if we can plug in some of the numbers that we have, we'll be easily able to find the missing side length. All right, so in the next part, we're going to look at some examples. Now, if you feel like you want to give this a try, I'd encourage you to pause the video here and take a look at this particular triangle. Once you look at it, you can try to figure out the A squared, B squared, C squared on your own, and then come back and we'll look at the process together. So if you'd like to try it, pause now. All right, here we're going to look at it together. So we know that C, which is labeled on here, is what's missing. Right? So if we're thinking A squared plus B squared, we're talking about the 6 and the 8. So A squared, 6 squared, right, is going to be our A side, plus B squared, or 8 squared, which will be our B side, equals C squared. So that's the first thing we're going to write out. Now, to solve this, we need to do our squares first. So 6 squared, or 6 times 6, is 36, and 8 squared, or 8 times 8, is 64. So we're going to add those two together. Right? 36 plus 64 is 100. And all this time, we're just going to carry down that C squared on the other side. So now we've solved that portion of it, we can see 100 equals C squared. Well, to get rid of that squared, right, and get C by itself, so we know just what C is, we have to be able to do a square root. So we'll do a square root on both sides to even it out. The square root of 100 and the square root of C squared. So remember, a square root is like the opposite of squaring something. A square root finds out what's one number that could be multiplied by itself to get the number that's inside the square root. So in this case, the number that you can multiply by itself to get to 100 is 10. And the number that you would multiply by itself to get C squared is just C by itself. The square root undoes the squared symbol. So here we find our missing length of C equals 10. Here's another chance to practice. So if you would like to try to solve this one on your own, feel free to pause the video here. All right, let's take a look at the solution. Here, you'll notice that we actually already have that C side. You see the right angle, it has a little box down at the bottom. And across from that right angle, we have our C length. It's 15. But what we're missing is B. So we need to keep the same order, right? A squared, B squared, C squared. So we'll find our A side first, right? Can't be that longest side, 15, so it has to be the 9. So 9 squared. B we don't have, so we'll just keep it as plus B squared. And then we'll put our hypotenuse in, 15 squared. So let's solve parts of this. 9 squared, or 9 times 9, is 81. We're going to keep the B squared there, and 15 squared is 225. So if we subtract instead of add, as you can see right now we have 81 plus B squared. If we subtract that 81, it cancels out that side on the left. And we just have to find out what 225 minus 81 is. So 225 minus 81 is 144. So now we know that B squared equals 144. Now again, we have to get to the root of this by trying to get the square root of both numbers. So if we get the square root of B squared, we'll end up with just B. They cancel each other out. The square root of 144, or again, the number that we're looking for that can be multiplied by itself to get 144, is 12. So just by using the different components that we have, even though we weren't looking for C squared here, we were looking for B squared, we're still able to solve it because we have 2 of the sides. So B equals 12. Thank you so much for watching today. This has been a great Pythagorean Theorem class, and I hope you learned something new. I hope you'll check out the Helms Academy by subscribing to our YouTube channel, by checking us out on Instagram and Facebook, and by going to helmsacademy.org.